This video is all about properties of p-n junction. At the instant of p-n junction formation, the free electrons near the junction in the n region begin to diffuse across the junction into the p region, where they combine with holes near the junction. The result is that n region loses free electrons as they diffuse into the junction. This creates a layer of positive charges, that is pentavalent ions, near the junction. As the electrons moves across the junction, the p region loses holes as the electron and holes combine. The result is that there is a layer of negative charges, that is trivalent ions, near the junction. These two layers of positive and negative charges form the depletion region or the depletion layer. The term depletion is due to the fact that near the junction, the region is depleted, that is emptied of charge carriers, that is free electrons and holes, due to diffusion across the junction. Remember the term depletion layer. Depletion layer is formed very quickly and is very thin compared to the n region and p region. Remember this one. Once p-n junction is formed and the depletion layer is created, the diffusion of free electrons stops. In other words, the depletion region acts as a barrier to the further movement of free electrons across the junction. The positive and negative charges set up an electric field. This is the direction of electric field from positive to negative. The electric field is a barrier to the free electrons in the n region. There exists a potential difference across the depletion layer and is called barrier potential V0. This is known as barrier potential. The barrier potential of a p-n junction depends upon several factors, including the type of semiconductor material, the amount of doping, and the temperature. The typical barrier potential is approximately 0.7 volt for silicon and 0.3 volt for germanium, and this figure shows the potential distribution curve. This is the depletion layer. This is barrier potential V0.